Hello. The recording with I've forgotten the software's name. Kazam, yeah. The recording with Kazam always blurs the beginning of my name, and as a result, it always blurs my name. So I'll repeat it again. My name is Wilson. It's not my real name, and neither is called Trilo, but I wanted to keep it secret. And because I want to keep my real name secret, I am recording this video with Dr. Racket. In Dr. Racket, you don't have to show terminal, and so basically you could start programming with this with Dr. Racket, and like you could type the code, so you could do something like this. I'm just trying to add two numbers. You can run it by pressing Ctrl and R, and it shows you the output. So why am I doing this? I'm actually building a SaaS, and the thing is that I don't want to share my SaaS videos related to my SaaS because it's not fear of copyright. It's just that my co-founder wouldn't appreciate it very much that I'm giving out too much information. I think I'll do some Twitter marketing related to it. And so the thing is, I want to make videos daily, you know. I want to grow this YouTube channel. I don't have a very good laptop at the moment, that's why I'm using Kazam. Otherwise, I'd be using OBS, and OBS is way better. And there's FFmpeg, which is also very good, but in FFmpeg, you use terminal, and then when I use terminal, you'll see my name, so FFmpeg is out of question. But there are indications that I might get a better laptop soon. So because I want to upload videos daily, I was thinking I'll do gaming videos because that's what I do, mostly Pokemon videos. I have so many Pokemon videos. And video games were just destroying my life, you know. It's not completely destroying my life, but I procrastinate a lot just by playing those video games. And so I thought I can make videos on this kind of thing every day, Dr. Racket, and upload them every day, and they don't have to be very long, and I don't have to show my name. I was thinking of doing coding in Python or coding in some other popular language, but these languages are, again, I don't want to show my name. Eventually I will show my name, eventually the world will know who I am. It's just I don't want to share personal things. So I've mentioned it countless times on this channel that this channel was inspired by TBTR, and the kind of content that TBTR shares, that'll get me into trouble. And like there's a lot of stuff. I haven't given too much personal stuff about my life, but in the Pokemon videos there is some personal stuff. It's very clickbaity. I'm gonna instigate people to look at all those videos, and then they'll scream through my personal stuff. There aren't that many personal things in there, but there are quite a few. But yeah, video games are wasting my life, so I'm gonna code with Racket, and this series is going to be called Daily Dr. Racket. And in Daily Dr. Racket, we'll go through this book, How to Design Programs, An Introduction to Programming and Computing. This book is by we can look. I mean, it's a very famous book. I don't even have to look at the author. It's by Matthias Felisen, Robert Bruce Findler, Matthew Flatt, and Sriram Krishnamurti. Yeah, that's it. He's the last author. There's no fifth author. Also, now there's another book like this called SICP, Structure and Composition of Programs. I don't know who it is by, but, and they use a Scheme. They don't use Dr. Racket, they use Scheme, but again, you have to use scheme using a terminal. I can use Dr. Racket, but just for the sake of consistency. These guys explicitly state that they're using Dr. Racket, so I will be using Dr. Racket in this, and this is why I'm going to use this book, because again, they are very explicit about Dr. Racket and SICP isn't. Although SICP is more popular, but I don't know how different the content is. And I went through SICP, and like the SICP lectures, the MIT ones, they're actually pretty good. I mean, the introductory lecture, I've watched a couple of them, and the first one was very good. So it talked about computer science, what computer science is, and it's basically, they say computer science is a wrong name. It's not a science, it's engineering. Although in one of the UC Berkeley lectures, he does mention that there is a science part to it as well. And it's science because, it's not a science because they are not studying the world, they're creating things, so it's more like engineering. But there are aspects of computer science where you are studying the natural world, like the automata theory. I don't know if you guys follow Stephen Wolfram. He does that kind of stuff, cellular automata, and that's where you are studying nature. And he said computer is also not the correct word, because computer means it's an instrument. It's like using, biology isn't about microscopes, but we use microscopes. So computers are tools that we use in computer science. I don't think this is, I mean, even in the SICP when I was reading, this definition of computer science wasn't there. And the second idea, the big idea that I really liked was, what's it called? Computer science is the study of understanding complexity. And basically when we are studying computer science, we're trying to manage complexity. Another great idea is that the engineering in computer science is not limited, it's only limited by our imagination. The real engineering, like mechanical engineering, like civil engineering, like aerospace engineering, it's limited by the physics, the constraints of physics, the constraints of chemistry, but the constraints of physical laws, but this form of engineering isn't. There is an aspect of hardware, but I don't know how it plays into this, the constraints of hardware. And there is another idea of recursions. That's one of the main ideas in this whole course, in this whole book, that it does not use loops, but it uses recursions. So I'll go through these books and I'll go through the questions, and you'll have videos daily. I aim to make them short, but with video games I'd make an hour-long video. And so when we go through the preface, I've highlighted this part. A typical course on programming teacher teaches a tinker until it works approach. When it works, student exclaims, "It works," and move on. Sadly, this phrase is also shortest lie in computing, and it has cost many people many hours of their lives. In contrast, the book focuses on habits of good programming, addressing both professional and vocational programmers. And you know, the funny thing is, I was going through this. I wanted to learn clean code because I didn't do a degree in software engineering. I'm mostly self-taught, and I have this philosophy as well. It should just work, but once it works, you have to write clean code. And I think the author of Clean Code, Robert C. Martin, he's a big. I don't know if it's Robert C. Martin or Robert C. Clark. I might be wrong on the precise surname. But he's a big fan of SICP. Not this book, but I think the principles are interchangeable. So by good programming, we mean an approach to creation of software that relies on systematic thought, planning, and understanding from the very beginning, at every stage, for every step. So I'll read parts of this book. I don't think I have to read the preface. I've highlighted parts like this. Programming design, but not programming, deserves the same role in a liberal arts education as mathematics and language skills. So this is the main part. So, and then I have highlighted a bunch of parts. I'll do the questions, I'll read through this, and you could see the 6 parts of here. from problem analysis to data definitions, identify the information that must be represented and how it is represented in the chosen programming language, formulate data definition, illustrate them with examples. So you have these steps, 6 steps, from problem analysis to data definition, signature, purpose statement, header, functional examples, functional template, function definition, and testing. This book is also recommended in the OSSU curriculum, and I got it from there. And I don't have the time to go through the OSSU curriculum now, but I'll get like 30-40 minutes every day that I can do this recording, and it's much better than playing video games. So I'll go through parts of this book, so you'll basically read and study it with me. I'll skip the preface because we'll learn everything, and I'll read everything in the book. There's also online documentation which I'd be reading, because like I said, I don't want to reveal my name, so this kind of thing, and it's very helpful. And this is basically, you have square, you have polygon, so I'd be reading through this as well. And we'll slowly go through this. Once I finish this book, I'll make projects. If by that time my SaaS goes big, then I don't know how much effort I'll put into this. Then probably I'll reveal my name, and then, but I think it's an interesting idea, Daily Dr. Racket. So stay tuned for more. We'll start the book tomorrow. Like and subscribe. Consider donating through PayPal. And peace out.